Okay guys, so the last example in this section that we're going to talk about is what happens if the radical function is not in the form where I can identify the transformations, right? What if I can't tell which direction it's moving? So for example, this one, the square root of 9x, it needs to be in this form. Notice in the parent function form, there's not a number right directly in front of the x, right? So somehow I need to rewrite this using the properties of radicals so I can get it in this form to identify my a, h, and k to figure out the transformations. The biggest thing that we need to remember about properties of radicals is this multiplication. Anytime that we are multiplying under a radical, right, that says the square root of 9 times x, we can rewrite it and separate those terms underneath the radical. So I can rewrite this as the square root of 9 times the square root of x. And what this allows me to do is now take the square root of 9. So what is the square root of 9? That's 3. And now my equation says 3 square root x, which now is in the form that I want it to be in. So now that x is by itself and I can identify this 3, what transformation does this 3 have on the graph? And that'll be a vertical stretch of 3. Okay, and that's all. We just have to rewrite these functions using the properties of radicals, and that's really the biggest thing. Let's take a look at another one here. So here's the equation. Square root of 4x plus 16 plus 7. Okay, not in this form, so we'll check out my properties of radicals. What we notice here is underneath the radical, I'm adding, right? So I can't separate anything just yet. Notice I can only separate when we're multiplying. But what I do notice as this whole radicand, so 4x plus 16, what can I do with just 4x plus 16? Hopefully we notice that there's a common term there, right? And I can take out the common term of 4, right? I could divide this by 4 and this by 4. What this allows me to do, now I have multiplication under my radical. Now I have the square root of 4 times x plus 4. And what can I do when I have multiplication under my radical? I can rewrite it and separate it. So now I can separate it and I can say the square root of 4 times the square root of x plus 4 plus 7, which lets me simplify once further and say the square root of 4 is 2 times x, the square root of x plus 4 plus 7. And I can identify my transformations, which are that 2 is what? That's a vertical stretch. The 4 moves it to the left 4, and the 7 moves it up 7. Okay, and that's all, guys. You just have to practice rewriting and finding the common term if you need to, so you can get it into this form and know how the graph moves. I know both of these examples are square root, but it could also be cube root. It could be anything, okay? Just have to take the correct square. Like here was square root. Well, this had to be like this. Those are square roots. But let's say it was like the cube root, right? Cube root of 8, you have to remember, is like 2. Okay, and if it was like this, for example, instead of the 4, like this would still be the same. When you separate it, that cube root comes with it. I just totally went on a side note here, but it's important. You know, like if the original is cube root, even when you separate it down here to the next step, it's still cube root. Make sure you go back to thinking about those cube roots. I know it's been a while. Okay? Good luck, guys. You'll do the try-outs in the practice section. Awesome job.